Okay, so we're still in 1.4. That is called the intermediate value theorem. So we'll title it 1.4. We will start to abbreviate this IVT because it's long. IVT. It's never perfect. Intermediate value theorem. Let's break it down so we know what it means. Intermediate. You guys see that word? What does that mean? Yeah. In the middle. Value. What does that mean? As relationship to a function. Mathematicians are not clever with the naming of their theorems. Either they name it based on what it does, like the squeeze theorem, or Pythagorean theorem. They name it after themselves. This one wasn't named. Was there some guy named intermediate value theorem? So basically, this theorem is just what the name, it does what the name says. So we need to break the name down. Value is a number. Which number? X or Y? Yeah, the Y value. So this theorem tells us something about a Y value in the middle. Sort of like 18 pounds in the middle of the other 2 pounds in our puppy situation. Okay, so I'll write out the theorem and I bet you guys could make a conclusion. So it starts off like this. All the theorems are if-then statements. The if are the conditions that must be met. So just like the Pythagorean theorem, you guys use the results all the time, but the Pythagorean theorem, the if parts are if it's a right triangle, if side lengths are a, b, and c, then you could do a squared plus b squared equals c squared. If it wasn't a right triangle, could you use the Pythagorean theorem? No. So all our theorems, we need to make sure we state the if parts, and then we just conclude for the then part. So this one actually has 2 if conditions that must be met. The first if condition, what do you guys think the first if condition would be? Yeah. If it's continuous, that part is important. So we'll just number it. If, I guess I won't number it. If f of x is continuous, n the interval a and b, this is interval notation, the open interval a and b. So sometimes it's not continuous in some other spots, but we're not concerned about it, so we're fine. But in the interval we are interested in, it must be continuous. So say you guys have the 1 over x function. It's not continuous at 0. So if we were to have a interval from -1 to 1, we will not be able to use the intermediate value theorem. But if we were at 1 to 7, that's fine. So this theorem only concerns about in its interval that it's defined, it must be continuous. So you guys are less technical here. You don't have to prove continuity, but you must acknowledge that the function is continuous. So you must write a statement, f of x is continuous, before you move on to the next part of the theorem. Okay, the second part of the theorem says something about the y value in the middle. So if f of x is continuous and the middle value, let's let f of c be a middle. To be a middle, it must be greater than f of a and f of b. What is f of a and f of b compared to a and b? A is the x or y value. F of a is the y value. Okay, let me get the graph going. Our conclusion comes up next. But let me draw you the graph and then see if you guys can think of your conclusion. Okay, so here's our graph. And let's just put A and B down. Let's toss A there. Let's toss B there. Let's make the first condition met. A continuous curve. Draw a nice continuous curve. That's there. So that's my continuous curve. Okay. This is A. The y value is f of A. This is B. The y value is f of B. Where am I going to draw f of C? In the middle, on this axis. So draw f of C there, in the middle. It has to be in the middle. This condition needs to be true. If f of C is in the middle, could there be a time between A and B that produces f of C? Yes, that is our theorem. That's it. The theorem says we can now guarantee x equals C. So this is an existence theorem. We don't have to solve for the C value between A and B. We just have to say, yes, it happens. So in our puppy situation, notice that 18 pound was between these Y values. You guys can guarantee, because it's continuous, in between, that there was a time between 12 and 15 weeks that the puppy was 18 pounds. Does that make sense? Okay, that is our theorem. And so let's write the conclusion. The conclusion can be kind of tricky because of the wording. So let's see if I remember correctly. Oh, this is the intermediate value theorem. You must use the name in your conclusion. So make sure you write the continuity. Make sure you write a in-between statement. And then your conclusion is by the intermediate value theorem, there exists at least one. Why at least one? Yeah.
Because the C value for while has to be reference.
Yes. What if this curve also turns around like that? There could be two, but we know at least one exists. There could be more, but this theorem guarantees at least one. So by the intermediate value theorem, there is at least one x equals C in our interval A and B. The C is in that interval. It guarantees a C in that interval. It doesn't guarantee a C outside the interval, such that f of C produces that y value. This is which in this case it will I just call it y. Okay, so the theorem says if you know it's continuous, if you know that it is between the other one, there exists a time in between these two that will produce that answer, that result. These are the results, these are the times. But you must check to make sure it's between, and you must check if it's continuous. So let's actually try a couple examples just to make sure. Try to make sense of this theorem. And eventually you can reword it a little bit different, but you want to have all the parts. The key parts is you do have to name it, because we will learn other theorems later, and you want to give the name. It's that theorem that guarantees at least one x value exists. So let's see how it works with an example. This is the example 3 in the back of your worksheet. Let's just try this one. I wrote it out so you guys could just you have it on paper. But let's do number 3. I'll rewrite it here. It's example 3 on that paper in the back. And it says there is an equation. The question wants you to show that there is a y value of 5 and the interval 1, 3. So it's really C is a variable we use to stand for the x value. So it's saying, was there a value on the x-axis that produces an output of 5 in our interval 1 and 3? Okay, so we have to make sure we meet all of the conditions of the intermediate value theorem. So first thing that you guys want to write down. Yes. F of x is continuous. How do you know? I remember if I mentioned this. Yeah, it's a polynomial. Or we could say because all polynomials are continuous. Okay. Sometimes if it's not a polynomial, you do have to explain a little bit more. If it comes to it, you can use your definition of continuity to prove it's continuous. But oftentimes it's in the problem. They would have already mentioned it somewhere in the problem. If they don't, it's because they're giving you a polynomial. Polynomials, again, wiggle in turn, but always continuous everywhere. Okay, first condition is done. Second condition, what also needs to be true for us to use the intermediate value theorem? The y value needs to be what? Well, okay, in the middle. Now, the y value does not have to be greater than 1 and 3. This is a y value. 1 and 3 is actually what values? X values. You need to compare the y value to the y values of these. F of 1 and f of 3. We need to calculate them. So let's calculate them. Let's do some work to calculate them. Okay, f of 1, that says plug it into that equation. You do your math. We got 1 minus 4, that's negative 3, plus 2, negative 1, plus 7, is that 6? F of 1 is 6. Okay. How about f of 3? So you don't want to compare it to 1 and 3 because that's a y value. These are x values. But you could compare it to f of 3 and f of 1. Okay. f of 3, I put 3 into that, I get 27 minus that, minus, plus that, plus that. Okay, you guys help me out.
4.
Is it 4?
Yeah.
It is 4. F of 3 is 4. Is 5 between 4 and 6?
Yeah.
Yes. Rewrite your in-between statement. 5 is between f of 3 and f of 1. Right, f of 3 and f of 1, so we know it's the y value when x is 3, the y value when x is 1. We will then come back and know what they are. Okay, we got our in-between statement done. We just have to finish the sentence. Okay, so we'll go back to our notes. We will say by the intermediate value theorem, there exists how many? At least one x equals c value such that when we plug the c value in, what are we looking to get out? A 5. A y value of 5. Let's also give a graphical picture of that so we know what we're looking at. What does that actually mean? Okay, so here's our graphical picture. We got a polynomial that's continuous. I think I'm going to do this. We are concerned about 1 and 3. We got that f of 1 is there, and we got that f of 3 is here. We know that our value is 5, and it's in between. F of c equals 5. F of c equals 5. Because it is in between, and because we have a continuous function, the intermediate value theorem guarantees an x equals c that produces a y value of 5. Oh, and I forgot one thing. It guarantees that the c is in which interval? And the interval 1 and 3. It won't be outside that interval. It will have to be in that interval. Okay, let me just give you a picture of why we need it to be continuous. Let me say, what if it wasn't continuous? F of 1 is there. F of 3 is there. And then we pick a f of c in between. Can you guys see why, if it's not continuous, the intermediate theorem doesn't work? We don't know. It won't guarantee any x that works. So that is an example of when we cannot use intermediate value theorem. Let's make a note. This part's also important. The intermediate value theorem is considered an existence theorem. It is an existence theorem. What that means is you can only use to prove that this exists. Any other case, You cannot say it doesn't exist. It will just be inconclusive. So prove x equals c exists, or inconclusive. So if it's not continuous, you would just say intermediate value theorem does not apply because it's not continuous. If you happen to test the endpoints and it wasn't in between, you would just say inconclusive because our y value is not between. You cannot conclude that no, it doesn't exist a x equals c, because it can still exist. It's just we can use it to prove this, or we don't know. Inconclusive, cannot be applied. All right, so let's add to this. What do you guys think I'm going to ask next? What follows this? No, nobody have a guess? Find the c value. Who's thinking of that? Okay, now this one only says a c value exists. It never said find the c value. If it never told you to find the c value, you guys don't have to find the c value. Now we're, but sometimes they will say, well, go and find the c value. The IVT guarantees there's a c value. Let's continue from this problem. And now our question is, same problem, but we are going to now ask to find the x equals c value guaranteed by our intermediate value theorem from earlier. So if IVT doesn't work, you're not going to go and look for a c value, but sometimes they'll say go and find the c value. The c value is the x value that produces an output of 5. So for this question, we will be setting it equal to 5. Now I designed this so that the x value is not a nice whole number. If it is a whole number, we could try some of our factoring strategies. But if it's not a nice whole number, and it's not a quadratic, to solve this, we will need the help of the calculator. All right, so how we're going to do this is we're going to go to our phone, and then we're going to download the Wabbit MU if you have a Samsung phone. In the Play Store, you will search WABB. Oh, you guys don't take out your phone. I was just showing you how this app. And then we'll find our calculator. It's our TI-84 on my Samsung phone, but Apples don't have it. So you're out of luck if you have an Apple phone. How cool is that? All right, I'll use my calculator. This is my phone, but that's my app. Okay, so maybe you can do that so you can use it at home. If not, you can use Desmos. So how this works is we probably want to graph this, y equals, enter it into y1, enter in 5 to y1. Now, if we can solve it algebraically, that will be to move that over, factor. Maybe you could try by grouping. You could try long division. This one just won't work because it's not going to produce nice whole numbers. So graphically, to solve this, it's just the point of intersection of a line y equals 5 and a line, a curve, a cubic curve. So I enter it in, I put one of them there. Your calculator normally starts off with a zoom standard, a 10 by 10 window. If it shows all the graph, you're fine. If it's not, you might zoom in, zoom out a little bit. But I think this shows all of it. There's the 5. That's this one. They're in red. This one's in blue. The x that produces the 5 is that intersection point. When this equation equals that, has the same meaning as the intersection point. There's 3 intersection points. Which one do I pick? Yeah, the middle one, because that is where it's between 1 and 3. This problem was from the previous one, and our interval was 1 and 3. Let's zoom in a little bit. Zoom in. Maybe just move our little cursor. That's probably where I want it. Okay, all the work that we do in here will be stored in the calc option right here. It's blue, so you guys would have to touch what first? Okay, calc. I'm looking for intersection. That is option 5. Scroll to option 5. Follow the instructions there. It says, where is the first curve you're interested in? You might have multiple curves in Y1, Y2, Y3. So it jumps on one of them. Oh, that curve, that's the blue curve. It jumps to the next one. Yes, that curve. Press enter. It wants your help. Yes. Now, if you want that one, you now move over close to that one, but I don't want that one. I want that one there. So I'm going to move it close to that one. Press enter. The intersection point is 1.311 and 5. So that means the C value is 1.311, such that when we plug that in, we get a 5 out. Guaranteed by the intermediate value theorem. Okay, let's try the next one. Okay, let's do number 7 on the back. Number 4 or 5 seems to be really similar, so let's do number 7. And then also practice the calculator. We'll add that one didn't ask us to find the C, but we'll just add it to it. Number 7. Okay. Those are just example problems I thought would be good for us to do. And then practice the steps again. Okay, show that this polynomial has a root somewhere between 1 and 2. What is a root? Yeah, an x-intercept. Since it intersects the x-axis, what's the value of your y? 0. So it's the intermediate value theorem. It's saying that could there be a y value of 0 in the interval -1 and 2 of this polynomial? Does it cross the x-axis? So a hint is that word, could you, could there be, does there exist? That's how you go to the intermediate value theorem. They're asking you to prove something exists. Does a y value equal 0 exist? Well, we'll know by the intermediate value theorem. So, first condition of the intermediate value theorem, we must state it, acknowledge it. What is it? P of x is continuous. Okay. Since it's a polynomial, you guys don't have to say because it's a polynomial, we'll just know. But you must mention it. P of x is continuous. Okay. Is 0 between -1 and 2? Yes, but that won't fit the intermediate value theorem because those are x values. So you must solve for the y values. Okay, plugging everything in. The bad thing about these phone calculators, they're not as user-friendly because it's not buttons. Oh, maybe you guys can calculate it in your head, but let's just test -1 in. So I'm going to plug it into this part. I got 8. I'll plug in a 2. I highlighted and paste and plugging in a 2. If you plug in a negative, don't use the minus, use the negative. I got a 19. Is the y value 0 between the other two y value? Yes, let's write our statement. Here's our first statement. Here's our second statement. 0 is less than or equal f of 1, greater than or equal f of 2. Since 19 negative is smaller than 0, we'll toss f of 2 here, f of -1 there. Our in-between statement is there. We're done. By our intermediate value theorem, there exists at least one x equals c. Oh, and the interval. Where is our interval? Such that if we happen to plug it into the p equation, it will produce a root. That means the y value is 0. Okay, our theorem guarantees there is a possible x or c. In this case, when we put it in, we get that. Let's add on. Find that c value. Okay, what do you guys have to do? It says find that c value. Find the x that produces the 0. Oh, so that option is it's a different option than intersection point because it's a 0. The 0 is actually in the count button. It actually is there. It's 0. It says find the x intercept. So you don't have to do intersection point. You really just need to enter in one equation, that equation that's there. Okay, I think I got it right. Graph. I only want to see between -1 and 2, so that's about the one in the middle right there. Let's do a second calc. A 0. A root is a 0. It is basically y equals 0. The calculator says pick left of where you think it is. It's right here. Left of it is there. It should draw a dashed line. Right of it, pick something right of it. Guess. Oh, I'm guessing right there. It tells you right up there that x is about 0.425. And the y value was the 0. So that means our c value is 0.425. That is when our graph has a root, when it crosses the x-axis. That is actually a value between -1 and 2, so we are fine. Now it says at least, so maybe when you guys look at -1 and 2 and there's multiple, then you can say, oh, see, there's these other two that also guarantees that. Questions? Yeah.
Will we be using graphic calculators on the test?
Not this test. This test, we will probably give you enough information, and you'll just have to use the theorems to conclude. Okay, so we will be looking for specific things if it was a test. I will be looking for, did you say p of x is continuous? If it's obvious, like a polynomial, just acknowledge it. Did you calculate the y values and make sure you know that it is between? Did you use the name and write a correct conclusion? If it asks for a c, go and find the c. This part, if it wasn't a calculator, that means that I will have to give you an equation that you could factor and solve for. So that might be some practice you guys need to do.